Today we'll be talking about unit conversions. And so we're going to do it as if we are given the factors already, like you guys will have in your blue packets. And so let's start talking about why we even do unit conversions. And so the use of using them is called dimensional analysis. And this is a way that we can just convert to different units of a measurement. And we use conversion factors. And so even though the value changes, you need to understand that it does not change the absolute quantity, just the units. And my example I'm giving here is if I tell you I weighed 1 gram of salt and I weighed 1,000 milligrams of salt, it's the exact same amount. So even though our values of 1 and 1,000 are changing, the absolute quantity is the same. So I wanted to start off with conversions that we know, something that you guys could do without my help, but just kind of explain a little bit how the work and setup should look like. And so what we're going to find out is how many seconds are in an 8-hour workday. And we're going to do a couple conversions here instead of doing straight from hours to seconds. And so you guys should be able to tell me that in 1 hour we know we have 60 minutes. In that 1 minute, we have 60 seconds. So how would we set this up? So we are going to be finding relationships or equalities just like this. And from each of those, you can write 2 conversion factors. And so what they look like are just fractions that will multiply against our value. So for this first one here, you could either use for every 1 hour, there's 60 minutes. Or you could write 60 minutes on top of your conversion fraction for every 1 hour. It just depends on the values given. You can do the same thing for the second one here and say 1 minute over 60 seconds or 60 seconds over 1 minute. So it all depends on what our path is going to be. But these are what we call your conversion fractions. And again, these are called relationships or equalities. So how I would start my problem is start with what we know. We know we have 8 hours. That's our only value given. And so if I start with my 8 hours, I'm going to get ready to multiply by a conversion fraction. So one thing I want you guys to think about, put your first value over 1. If it just has 1 unit, it's just over 1. This will help you realize, oh, hours actually in the numerator. So when you go to pick your conversion factor out of these, it's easy to figure out which one you should grab, knowing you want to cancel out the unit hours. If it's on the numerator here, we're going to want it on the denominator of our conversion fraction so they cancel. So we're going to select this conversion factor. So 60 minutes over 1 hour. Now we're ready for our second one. Same idea here, except now we can cancel out hours. We are in units of minute. Again, that's on the top. So we're going to find the conversion fraction that has minute on the bottom. It's this one. We're going to place it here. So then we will have 60 seconds over 1 minute. Now we cancel out minutes and we're left in units of seconds, which is what we want. We are able to put this in our calculators now. And so typically, there's a couple different ways you can. Now it's easy because our bottom numbers are all 1, so they're not going to change anything. But what I tell my students is multiply by anything that's in the numerator and divide by anything that's in the denominator. In our case, we're just taking 8 times 60 times 60. Your answer would then be 28,800 seconds. All right, now let's get into the metric system. So for this, you guys will be getting table C in your blue packets, like I said. And so what these prefixes are, what they mean is just the factor given. So kilo means 10 to the third. Milli means 10 to the negative third. That's what these prefixes are to represent. And so really what we have to remember, even though it's not on here, in between kilo and deci, we have our base unit. And remember, these can be things like meters, grams, liters, second. I mean, I could keep going on. These are things that don't have a prefix. These are our base units. And so the factor that they get is actually 10 to the 0, or as we know, that is just 1. So it's good to remember that even though it's not on your table, the base unit is 10 to the 0, or 1. And so the first thing we're going to do is define these relationships, and then we're going to create conversion factors from them. So grams is one of our base units. So we know that that is 10 to the 0. And we're converting to milligrams, so if we look at our table, milli is 10 to the negative third. And what we're going to do is compare the difference in factors. So if you look at the difference between the two, it is a difference in 10 to the 3 power. So I want you guys to think of this as a scale. And we're always taking the absolute value of the difference between the two. Now that we know the difference, if we're setting up the relationship or the equality between grams and milligrams, you are going to give a 1 to the larger value, the larger unit. So in our case, if this is where our base unit lives and this is where milli is, base unit is higher. It is larger. Grams is a larger unit than milligrams, so it gets the 1, and we'll give milligrams 10 to the third. So now that we have our relationship, we can write our two conversion factors like we did up above here with minutes and seconds. And so you can either write for 1 gram, there's 10 to the third milligrams, or 10 to the third milligrams for every 1 gram. Doing this for kilometers and centimeters. Kilometer has 10 to the third. Centi has 10 to the negative second. So looking at the difference here, and I want you to think of it as a scale, as if we are going from 10 to the third all the way to 10 to the negative second. How many powers of 10 between is that? And so the difference here is actually 10 to the fifth. So think of this as 10 to the second, 10 to the first, 10 to the 0, 10 to the negative 1. So there are 1, 2, 3, 4, 5 powers. So that's where that 10 to the fifth comes from. And if we write our relationship, we realize that kilometers is the larger unit, so that gets the 1, and that will be equal to 10 to the fifth centimeters. Now our conversion factors will be 1 kilometer over 10 to the fifth centimeters, or 10 to the fifth centimeters for every 1 kilometer. Practicing one more with picoseconds and nanoseconds. Pico has a value of 10 to the negative 12th, nano 10 to the negative 9th. The difference between these are 3 powers of 10. The larger of the two is nano, so for every 1 nanosecond, we have 10 to the third picoseconds, giving us the two conversion factors of 1 nanosecond for every 10 to the third picosecond, or 10 to the 3 picoseconds per nanosecond. Now, one thing I want to point out, you may know, or you can use your calculator, that 10 to the third is the same thing as 1,000. I am totally okay if you guys use the whole number and not the power of 10 in your conversion factors, but makes no difference. Just wanted to point that out. All right, let's do some practice problems now. So, in this problem we're given that we have 155 milliliters. How many microliters do we have? So the first thing I'm going to do is recognize the units I'm converting between are milliliters and microliters. If I were to look at table C, I would notice that 10 to the negative third is the factor belonging to milliliters. and 10 to the negative 6 is the factor belonging to microliters. The difference between the two is 10 to the third. Microliter is the larger unit, milliliter. So 1 mil, there's 10 to the third microliters. Now, instead of setting up my fractions, I'm going to first start my problems, since we should be pretty familiar with how to do that. And so I'm going to start by writing what I know. Well, I have 155 milliliters. Again, I'm going to put this over 1 to remind myself it's the milliliters in the numerator. Just dividing it by 1 does not change the value. And I'm going to get ready to set up my conversion factor. Now, we know we're going to put one of these values on the top or bottom and put the other wherever the hole is. And so what I like to recognize first is that we want to get rid of milliliters, which is on the top. So we're always going to place that unit we want to get rid of on the bottom then. So we're going to place 1 milliliter here, 10 to the third microliters on top. In our calculators, I would take 155 times 10 to the third, or 1,000, and you ended up getting 155,000 microliters as your answer. All right, let's do the next one. We are going from centimeters to kilometers. Again, recognizing the factors off of table C. Centimeters has 10 to the second. Kilometers has 10 to the fifth. Oops, sorry. That's the difference. Spoiler alert, 10 to the third. And the difference between the two is 10 to the fifth. Again, defining that relationship, giving kilometers the 1 because it's the larger unit. And now I'm going to get ready to start my conversion. So if I have 32.1 centimeters over 1, my conversion factor, I'm going to make sure to place centimeters on the bottom so that it cancels with my original value. And my target is kilometers. So another little thing to tell yourself is put the target unit on top. Now, in your calculators, you're going to take 32.1 and divide it by 10 to the fifth, or 100,000. So in our case, we would get 0.000321, or if I were to convert that to scientific notation, 3.21 times 10 to the negative fourth kilometers. Either are acceptable. On a test, I may ask for one form or the other. On the next one, we are going from nanometers to meters. Pulling their values from table C, nano is 10 to the negative ninth. Our base unit is 10 to the 0. So the difference is 10 to the ninth. So we say for every 1 meter, we have 10 to the 9 nanometers. Starting our problem, 433 nanometers over 1. We are going to multiply that by 1 meter over 10 to the 9 nanometers. In our case, again, we're taking 433, dividing it by 10 to the 9th, and we end up getting 4.33 times 10 to the negative 7th meters. Now, if I ever ask you to show work, this is what I need to see. This is the minimal amount of work I need to see. If I ask for a relationship or an equality, that's this right here. And again, if I ask for the possible conversion factors, that's going to be these two options here. But I just wanted to specify the minimal amount of work would be this right here.